You ever feel like you're juggling, I don't know, a million different things with not nearly enough time or money? Well, it turns out there's a mathematical way to find the absolute perfect balance in situations just like that. Today, we are diving into the Optimizer's toolkit and pulling out a seriously powerful method called linear programming. Seriously, it's designed to help you make the best possible decisions, and honestly, it's a complete game changer.
I mean, this is the big question, isn't it? Whether you're running a massive global company or, just trying to figure out your weekly grocery budget, you've got limits. You've got limited resources. And getting the absolute most out of them, that's the challenge for all of us. And today, we're going to learn the actual mathematical framework for cracking that code.
All right, so let's start at the beginning. What exactly is this thing, linear programming? We're about to define this core tool and really get how it helps us find that one single best possible outcome from a whole sea of different choices.
Okay, I know, that sounds super academic, right? A bit of a mouthful. So let's just translate that. A really great way to think about it is like a GPS for your decisions. You tell it your destination, that's your goal, like maximize my profit. Then you tell it the rules of the road. Those are your limitations, like your budget or how much time you have. Linear programming then just calculates the single most efficient route to get you there. It's math that finds the sweet spot.
And here's what's so cool about this. Every single one of these problems, I don't care how mind-bogglingly complex it is, it's all built from just these three simple parts. You've got your objective function. That's just what you're aiming for. Then you have the decision variables. Those are the levers you can actually pull, the choices you can make. And finally, you have the constraints. Those are the rules of the game, the limits you have to play within. That's it. Your goal, your choices, and your limits.
Okay, so this is where things get really interesting. For problems that aren't too complicated, you don't actually need some giant supercomputer. You can literally see the perfect answer, just laid out right in front of you.
It turns out, if you're only juggling two of those decision variables, let's say how many of product A to build versus how many of product B, you can map out the entire problem on a simple graph. This is our first tool, and it's awesome because it's so visual, the graphical method.
So here's how it works, in just 4 steps. First, you draw your limits, your constraints, as lines on the graph. This basically fences off an area of all the possible good solutions. We call this the feasible region. Now here is the magic part. The single best answer, the optimal solution, it's not hiding somewhere in the middle of that shape. It will always be sitting at one of the corners. So all you have to do is check the value at each corner and boom, one of them is your winner. It's that simple.
That graphical method is brilliant, right? So simple. But what happens when our problems get way more complex? What happens when they're way too big to just draw on a piece of paper?
Exactly. You literally can't draw a graph with 1,000 dimensions. I mean, I can't. So this is where we have to leave the pictures behind and call in the big guns, the real computational power of linear programming.
And that big gun is called the simplex method. It was developed back in 1947 by an absolute genius of a mathematician, George Dantzig. And this is the powerhouse algorithm that solves those massive, real-world problems, the ones with thousands of variables that we could never, ever hope to visualize.
The genius of the simplex method is that it's basically doing what we did on the graph, just with pure algebra. So imagine it starts at one corner of that crazy, multidimensional shape. It then cleverly hops to a neighbor corner, but only if that new corner gives it a better answer. It just keeps hopping, from good corner to better corner, improving its answer with every single step, until it finally lands on a corner that just can't be beat. It's a smart, systematic search for the absolute best.
So what does that whole hopping process look like to a computer? Well, it looks something like this. This is called the simplex tableau. Now don't worry, you do not need to understand the math here at all. Just think of this as the algorithm's dashboard or its control panel. Each row kind of represents a corner, and the algorithm uses all these calculations to decide which corner to jump to next to make the solution better. It's the engine that lets the machine navigate those thousands of dimensions for us.
All right, now for a really fascinating twist in this whole optimization story. It turns out that every single linear programming problem has a secret twin, a hidden mirror image problem that gives us a totally different but just as important perspective on what's going on.
Okay, imagine a producer, right? Their problem, the primal problem, is to maximize their profit from all the stuff they make. Now let's flip the script. Imagine a buyer. Their dual problem is to buy up all of that producer's raw materials for the lowest possible price. And here, this is the incredible part. The answer to the producer's maximum profit problem is exactly the same as the answer to the buyer's minimum cost problem. It shows they're just two sides of the very same economic coin, and it reveals the true underlying value of the resources themselves. Pretty cool, huh?
So, we've found the perfect answer. Great. But we all know the real world is never that clean and simple. Costs change, supply chains break, things happen. This is where linear programming stops being just a way to find an answer and becomes a seriously powerful strategic tool.
This is basically the what-if machine. We're talking about sensitivity analysis. It lets us stress test our perfect solution against the absolute chaos of the real world. You know, what happens to our amazing plan if costs suddenly spike or a key supplier is late? This tool gives us the foresight to find that out ahead of time.
So this analysis lets you ask those really crucial questions. It helps you find the breaking point. Like, how much can a price change before your entire strategy just falls apart? It transforms a single static number into a dynamic, flexible understanding of your whole business landscape. You're not just finding one plan. You're building a tough, robust strategy that can actually handle uncertainty.
And there you have it. From a simple picture on a graph to the powerful engine of the simplex method and the deep, deep insights of duality, linear programming is so much more than just math. It's a powerful way of thinking that just brings incredible clarity to our most complicated decisions. So now that you know the tools, what part of your world are you going to optimize?